All right, cool kids, welcome back to Nick Does Maths. I am Nick because we're going to do maths. I have condensed a mechanics question down to this much stuff. What have we got? We're going to do some 2D impacts. We've got one particle here, mass 2m, going kaboom. And weirdly enough, it's a smaller particle, but mass 3m is coming in from down here at a vector of 3 meters per second, going kashponk. They are going to, their axis of impact is perpendicular to the vertical. That's going to be important. We know the coefficient of restitution between these two things. Find the kinetic energy lost in the impact. Right, now, things to note, and this is going to happen a lot in 2D collisions, is, let's use some green, is because the impact here is, all right, perpendicular to the vertical, what it means is the impact is only really vertical. Only the vertical components, the j components of my velocities are going to be affected. So what it means is I can say, now I'm going to assume that this is going to bounce up this way. That is still going to be a 3, but I don't know what its vertical component is going to be. And this is going to bounce down here. It will still have a 2 as its horizontal or I component, if I'm doing this correct. And I'm going to write that as minus v. I'm going to write it as minus v. That way v is positive, going downwards. If I got it wrong, I'll get a different sign out. I'm just going to assume this for now. All right, so that's the setup for me. And it's the fact that this impact is only happening really in one direction. And you will see when you do these 2D impacts, trying to think on top of my head, I think all of them, either the impact will happen completely vertically or completely horizontally. So one of these two components will not change. Okay? So really, in terms of my two balls, where the collision happens is vertically. All right, so that's why this is going. All right, find the kinetically lost in the impact, yada, yada, yada. I'll deal with that later. I've got an impact. I know what I need to do. We're going to look at conservation of momentum. Let's look at conservation of momentum. We should do this really with vectors. So, starting momentum from particle A, 2m, 3 minus 4, plus 3m, 2, 3, particle A, particle B, is equal to 2m, 3u, plus 3m, 2 minus v. Now, the m's go bye-byes. Bye-bye m's. Too many m's. Which makes sense to me. It's all scaled up or scaled down. Now the I components obviously all work. I've got nothing to change there. But if we look at the j components, I get minus 8 plus 9 is 2u minus 3v. 1 is 2u minus 3v. Okay, equation 1. Now let's do an impact. So, what is my speed of approach? This is jetting down at 4 meters per second. This is coming up at 3 meters per second. So, my speed of approach is 11. 7. Well done, me. I can do maths good, I can. 4 plus 3. So that's coming down at 4, that's going up at 3. So my speed of approach is 7 times E. And that's got to equal to my speed of separation. Well, if this is going up at u, this is going down at v, this is going to be u plus v. So ultimately, what am I solving? I'm solving 1 is 2u minus 3v, equation 1. And from here, 3 is u plus v, equation 2. All right? Now, what might we do? Let's do equation 1 plus 3 times equation 2. All right? That will get rid of the v's for me. So 1 plus 3 times 3 is 10. 2 plus 3 times 1 is 5. That is going to tell me that u is 2. Plug that back into equation 2. That tells me that v is 1. Wicked, I didn't get a negative. So it tells me my intuition that they will bounce. That will bounce back up that way, and this one will bounce back down. All right? So what I've now got is that, in fact, that's going down at -1. Right, the minus, right, if you're a tool, minus was built into here. The minus was built in there, it was built in there, all right? So I got V as 1, I had minus V, so it's -1. U is, what did we say U was? 2, okay. Awesome. Right. Well, we're not done. We're not done. We need to find the kinetic energy lost in the impact. So how much kinetic energy did I have to start with? Remember, kinetic energy is mv squared over 2. Now, that is speed. That is my speed that I want. Let's say that again, speed. All right, that is speed. So I need the modulus of this bad boy squared. So how much did I have to start with? I had, that's got 2m. Now, the v squared of that one is 3 squared plus 4 squared over 2, mv squared over 2. And this one here, plus 3m times 2 squared plus 3 squared over 2. All right, this is just my speed squared, bit of Pythagoras for us. Okay, so what is that? 3 squared plus 4 squared is obviously 25. 2 squared plus 3 squared is obviously 13. So that is, 2 times 25 is 50 plus 39. That is 89 m over 2 at the start. Joules. What's my kinetic energy at the end? So I get 2m times 2 squared plus 3 squared over 2 plus 3m times 2 squared plus 1 squared over 2. Well, what's that? 2 squared plus 3 squared is 13. 2 squared plus 1 squared is 5. So I end up with 26 plus 15 is 41 m over 2 joules. So what's the difference between the two? What is my loss in kinetic energy? Start minus end. Let's subtract them. I end up with 48 over 2 m joules. Obviously, we should simplify that to get 24 down there. Nice. Oh, nice. Yeah, nice little bit of collision work there. Just takes up a little bit of space. Not the most complicated one, just a few things to keep track of. As always, make sure we get the geometry of the impact correct. And also we're then looking at the kinetic energy, making sure that we realize that that in kinetic energy is the speed, so the modulus of my velocity. It's quite nice that it's squared because I don't have to deal with the horrible square roots. I can just rock and roll with the red numbers and we are all good. Bosh. Lovely. Well, if you enjoyed that, don't forget to subscribe, like, leave a comment, hit the bell so you know when the next one of these is coming out. So coming up as well, we've got some Easter revision. I'm running courses on the 6th and the 13th, which should be Sundays. That is of April, so the 2 Sundays leading up to Easter Sunday. If you just want to just go over, like we'll be doing about 3 hours in the morning, 3 hours in the afternoon on both days, just focusing on getting all of the core pure maths done, all right? And in terms of options, we'll be doing 1 afternoon of mechanics, 1 afternoon of statistics, okay? And get you fighting ready heading into your exams, okay? So just the link should be down in the description if you want to investigate that a little bit further. We are also doing a taster stream on the 2nd of April in the evening. If you just want to come hang out, see what it's all about, ask me questions about the revision courses themselves. Again, you should find a link somewhere in the description below. All right, I'm Nick. This was some maths. Hope to see you again soon. Bye-bye.